So we've been able to respond to recycler view clicks, toggling the checkboxes. And not only that, but then we can update the task. You can see when I check my brand new task, the is complete value turns to 1 and 0, 1. But we have a slight problem. If I were to run this app again, well, we've restarted the app. The data should be saved in the database, but we don't have the fact that the brand new task item was completed with the checkbox there and the another one task was starred. We're not actually showing it in the UI. When the user taps it, well, the checkbox is going to go on and off, but when the list first loads, we aren't actually assigning these checkboxes to be checked or not depending on what the data is. I can show you that the data is correct in the database, going to App Inspection here on the left, or if you don't see it there, you can go to the 3 dots and find it in here. But I've got my App Inspection here, and when that loads, I can go to the task table. I can see that task 1 is complete and that task 2 is starred, but not in the UI. So we'll do a couple of things here. We'll make sure that whenever the list first loads, these checkboxes are either checked or unchecked depending on what the data is. And we'll also strike through the text to give it a real feeling of being complete, if indeed the task is complete, not if it's starred. Okay, so back in Android Studio, we can close the database inspector and the project pane for now. So first of all, whenever we load the list and we create a new view holder for the task, well, we receive the task data here in the bind function. So I can do binding dot and then our checkboxes. So we'll start with the first checkbox. And this has a simple property called isChecked. So we can do isChecked and then we can set that to be equal to the task dot isComplete. Simple as that. If I go ahead and run the app, you can see there my brand new task is marked as complete when we load the app for the first time. So that is reading the data from the database correctly. So that's nice and easy. Do feel free to pause the video and go ahead and do the same for the star checkbox. Same concept. For those of you who want to see, it is binding dot, and it is our toggle star that we called it, dot is checked, and that could be equal to the task dot is starred. And again, if I run this, well, that shows correctly. Fantastic. So a final bit of UI we should do is actually when the task is completed, cross out the text. That really gives a feeling of it being complete. This is something that we only want to do if the task is completed. So we can do an if statement and say if the task dot is complete, and then we can write our code here. Now there's actually a few ways to strike through text in a text view. 3 major ways. I'll be showing you the easiest, but another nice mini challenge you could do here would be to pause the video, go on Google, and go and find out yourself how you can strike through text in a text view in Android. It's very straightforward. So a thing called paint flags, a thing where you just set some HTML. You can actually write HTML and do a strike tag, which is a HTML thing to strike through the text. That's another way of doing it. And then you might encounter a more modern way, although slightly more complex way, using a thing called a spannable. Any of those 3 is absolutely fine. So if you've used HTML or if you've used the spannable approach, that's fine. I'm going to go for the really simple way. So we do binding dot text view title dot, and then it is paint flags. And then you do a very simple thing, equals paint dot strike through text flag. We add this text flag there. We'll do the same on the description, so text view details rather. So if we go and run this now, well then you can see that our completed task has been crossed out, which is fantastic. Just a quick note to say that if you found an answer to do with paint flags online, like Stack Overflow or somewhere else, the full answer that you might have seen includes making it equal to the original paint flags. So I'll do text view title dot paint flags and then or like that, which is a slightly strange syntax. You would see it as pipe pipe if you're using Java, because that's the way you do or in Java. But in Kotlin, you just type or. So strictly speaking, we're supposed to do this, keep any of the original paint flags, or if there are none, then we can set the new ones. So feel free to do that to be by the book. Okay, you'll see that when I run this, it has the same effect. So we still have those paint flags there. But that is the nice simple UI now. So when the user loads the app, it will display correctly. We have a slight problem in that when they uncheck it, well, the UI doesn't uncross the task. The task remains crossed. But we'll actually be able to solve this problem by fully refreshing the task list whenever a task is updated. And we'll look to do that in the next tutorial. We've got the UI for making sure our checkbox is checked if the task is complete, making sure the star checkbox is checked if it's starred, and now also the text having the strike-through effect if the task is complete. However, whenever the user makes any updates, well, we're not seeing any of those changes. You can see if I check the second task, nothing happens. If I uncheck the task, nothing happens. Okay. And the simplest way to have the UI updating is whenever the task is updated with our listener there, simply refresh the tasks. So we'll go back to the tasks fragment where we implement the onTaskUpdated function. So tasks fragment, and then at the bottom we have onTaskUpdated. You can see whenever the recycler view is interacted with and a task is updated that we open a thread and update the task, but we don't actually do anything with the UI. So refreshing the tasks is as simple as calling the fetchAllTasks function again. If we go ahead and run this, okay, I can see my second task, which is completed, has the strike-through effect, and when I uncheck it, well, the list refreshes and then the strike-through is removed. Likewise, if I select a task, the strike-through effect is applied, and I can do that, change and change. So refreshing the list was as simple as writing one line of code to fetch all the tasks again after we update it. So that's pretty much all there is for this tutorial, really short. However, if I just close the run pane, let's see what actually happens when we update a task. We call fetchAllTasks, and what do? Well, we get all the tasks again, that's fine, but then we actually create a new tasks adapter from scratch every single time we call the fetchAllTasks function. So every time we call this, every time we update a task, we're creating a brand new adapter and setting it on our recycler view each and every time. And this isn't efficient. The Android system will have gone to the effort of creating the tasks adapter, and if I just go into that, which then creates all the view holders for all of the visible tasks, and then binding them to the tasks. And for every single time that we're updating the tasks, this is going to happen again. We're going to make the view holder from scratch. We're going to inflate the layout from scratch, and we're going to create all of these views on the screen. Okay, most phones are fairly powerful and efficient, so you wouldn't necessarily notice the performance issue there. However, we could and should do better. So in the next tutorial, if I just go back to the tasks fragment, we will look to improve the fetchAllTasks function. So rather than making a brand new tasks adapter every time we update a task, we will instead have just one tasks adapter. Following straight on from the last tutorial, where we learned that it's not efficient to keep creating a brand new tasks adapter every time we refresh the tasks, let's go ahead now and refactor the adapter to vastly improve the performance of this code. So rather than making the tasks adapter every time, what we're going to be doing instead is creating the adapter once as a class property, somewhere up here, and then simply providing the adapter with the updated tasks each and every time. And the first place we're going to have to start to make this change is inside the adapter. So in the tasks adapter now, we're no longer going to give the tasks when we make the adapter, so we're going to remove the tasks from the constructor. We'll simply provide the listener, which is the tasks fragment. You can see we have a couple of errors because we no longer have a tasks property. So what we're going to do instead is set it as a variable. So private var, a variable that we can change later, tasks of type list of task. And we'll make that equal initially to an empty list. So just list of. Okay. So when we first make the tasks adapter, we do have a tasks list, but it is empty. So get item count will equal 0, so no view holders will be created. I'll quickly do an auto format. And what we're going to do is we're going to make a public function that we can call from the tasks fragment. So underneath onBindViewHolder, make a new function, and we can call this setTasks. And we will pass in a list of tasks. So again, this is a list of our task object. And then what we'll do is the tasks property on line 14 here. So this.tasks, that refers to the property tasks, can equal the tasks that we've passed in. Remember, if you just do tasks without the word this, it thinks we're talking about the argument, the function parameter, okay? So we do this.tasks to be explicit that we're referring to this adapter's tasks, the property. So set tasks, this.tasks equals tasks. But that's not all that we need to do. Just giving the adapter the new tasks won't actually do anything. We need to tell the adapter to rebuild itself. We need to say, hey, task adapter, there's some new data now, so you may need to make some new view holders or update the data. And the way we do that in a recycler view is with a function called notify dataset changed. And what that will do is it will tell the adapter we've got some new data, so start again, get your item count, see how many tasks you have. You might have some more, you might have some less, you might have none, and then it will get to work. It may create some new view holders, or it may reuse the previous ones, and then it will bind all the new data. So this will happen again on bind view holder. It will go through all the tasks, and then it will update the data. So this is now a lot more efficient. We'll be reusing any previous view holders if we have some on the screen already, so it won't be inflating every single view holder again. If we had 2 view holders and those tasks have just been updated, it won't create any new view holders, it will reuse them, and instead it will just bind the data again. So that's already going to be a massive improvement, not rebuilding all of the view holders, not inflating all of the layout files over and over. We're getting a warning saying it's not necessarily the most efficient way to do it. If you hover over this, it says it's more efficient to be more specific if you can. There are advanced ways where you can inspect the exact task that has changed. But that's too advanced for the purpose of this tutorial, so we can actually safely ignore that warning. In fact, I'm going to suppress it by doing Alt-Enter and just suppressing that warning. That one's not a big deal. So that's the change we need to make in the adapter. We remove the tasks from the constructor. So initially you make a tasks adapter and it just has an empty list of tasks, but then we expose a set tasks function. We can pass in the updated tasks, set it in the adapter, and then just let the adapter know we've got some new data. So that's all we need to do here. So back to the tasks fragment. So we've got some errors now, but actually we're going to fully remove this line where we set the adapter. So we'll delete this altogether. And instead of making the adapter over and over again, we're now going to create it as a tasks fragment class property. So we'll do private val, because we're going to create it once and just leave it. We'll call it our adapter, and that can equal a new tasks adapter. And this time we don't pass in the tasks, we just pass in the listener, which is this fragment. If I scroll up, you can see the fragment is the task updated listener. So that's all we need to do to make one adapter that the fragment can then remember. Good. And then what we'll do is, in onViewCreated, one time, just before we fetch all the tasks, we'll go ahead and set this adapter on our recycler view. And this can be a one-time thing. So recyclerView.adapter equals our one adapter that we have in our tasks fragment. And initially, if I go ahead and run this, well, we have no tasks because we create the adapter and we set it on the recycler view, but when we fetch the tasks, we don't do anything with them. And so our updated code, we will simply do our adapter.setTasks, and that can equal our tasks that we've got from the database. And so now when we run this, you can see that we do have our tasks. And indeed, when I check them, they seem to cross out. Absolutely fine. But we've now actually got a few bugs. Because we're not making a brand new adapter from scratch, we're reusing the same view holders. We have an issue when, if I uncheck the tasks, they don't remove the strike through. And we have another very strange bug where if I were to toggle the star and then mark it as unchecked again like this, we get some slightly strange bugs where things are behaving in a very bizarre way, toggling on and off. Okay, so in the next tutorial we're going to fix these bugs. These bugs have come about because, back in the adapter, we're now not making a brand new adapter from scratch, but we're instead updating the data, notifying that our dataset has changed. But in many cases we're going to be reusing the same view holders. We're not making a fresh view holder from scratch, we're using the previous binding, the previous checkbox and text view. And you can see for our complete tasks, well, if it's complete, we add the strike through, but we don't do anything if the task is not complete. We don't remove the strike through. So in the next tutorial, we'll look into being a bit more disciplined in our view holder as we are now reusing the previous view holder. So now that we're using the same adapter and simply updating the data with set tasks, we've discovered there's a couple of bugs that we have to fix. And for our learning, it's actually fairly useful that we've seen these bugs because it helps teach us something very important about the recycler view. Take the name recycler view, something that recycles its views. As we briefly discussed in the last tutorial, when you first make the adapter, well, it's going to build all of the view holders that it needs for each task item from scratch. However, when you notify the dataset has changed, you can see where I've put a breakpoint there. Well, if it doesn't need to make any new view holders, it's going to recycle and reuse the existing ones. If some of this seems confusing, the easiest way for me to show you will be using breakpoints and debugging. So I'm going to put a breakpoint on line 20 for me at the start of my onCreateViewHolder, so we can see when the onCreateViewHolder function is called. I'll do another one for onBindViewHolder. That's where we give the individual task to each view holder. And then I'll put another one right at the top of the bind function there. So let's go ahead now and run this app in debug mode and see what happens when. Okay, the first breakpoint has been hit in set tasks. So initially we have an empty list of tasks before we provide the tasks to it. So no view holders are created because we had no tasks. And then, just looking back in tasks fragment, the fetchAll tasks function is called, and then we call set tasks. So actually, this set tasks function is the first thing that we hit. So I'll click the continue button, this one here, to go to the next breakpoint. And then we hit the onCreateViewHolder function one time, and then the onBindViewHolder function one time for the first task, and then the bind function, where we set all the data for that first task. And then it does all of that again for the second view holder, the second task. It creates another view holder, and then onBind view holder, and then bind again. Well, if I load the emulator, and this time I update one of the tasks by simply marking it as complete, let's do that. We get notified dataset changed. That's expected. We're setting a new list of tasks. But look, we go straight to the onBind view holder. OnCreate view holder doesn't happen again. And this is the whole point of the recycler view. If I just scroll up, we've only got 2 tasks in view. There are no additional tasks off the screen. So we have 2 tasks, 2 view holders already made. We're updating the tasks. We still have 2 tasks. So rather than inflating another layout and making another view holder, which is very wasteful, very inefficient, all we're going to do is use the previous view holder and then bind the new task to it. So if I continue again, then we hit the bind function. But look here, we're on line 38, right at the start of the bind function. I can see, having marked it as complete, it now says is complete true. But if I go ahead and inspect some of these binding views, for example the text view title, we'll see that we still have the previous values there, as this is a reused, a recycled view holder. The way you can inspect pretty much any view, you can do using this and find the binding and do it that way. Text view title, okay? But an easier way, if you click the 3 dots here, there's a little calculator that says evaluate expression. And this gives us like a little code editor that you can see here. So I can go and start typing some of the variables we have. I can see the binding, that auto-completes. I can do text view title.text to see what this value is. And when I click evaluate, I can see the value is still my brand new task. Looking at the bind function, we haven't hit the line yet where the task is assigned, the task title is set. So this proves that we have the value from the previous view holder. I'm hoping that some of this is making sense, that we are recycling the previous view holder, and everything that was set before, well, that's going to remain unless we explicitly set it again. And this explains the problem we have with our strike through. If I close the evaluate dialog, we set the strike through flag if the task is complete, but we don't clear it if the task is not complete. So if I actually now click this icon to mute all of the breakpoints, you can see the Alterna white or grey colour there, and then click continue. Looking back in the emulator, selecting a task, even though it reuses the previous view holder, that's no problem because we add the strike through flag, so that's fine. But if I deselect it, it doesn't clear the flag, and that's because we are recycling the view. We have the previous view holder, and unless we explicitly set every single value that we want to set, well, it's not going to clear things, it's not going to update things. So to fix our first problem, we can do an else block for task is complete, and we can clear those flags with binding.textviewtitle.paintFlags equals, and then 0, as funnily enough, a flag is an integer, a number, and 0 just means no flags. So we'll do that for the text view title, and I can duplicate that, and we can do that for the text view details. And simply put, that's going to fix our first bug, as even though we're reusing the previous view holder, well, if it's complete, we add the flag, and if it's not complete, we clear the flag. So let's run this now in normal mode, no need for debug. We add the flag, no problem, and then when we uncheck it, it clears the flag. So that is our first bug fixed, and in order to fix that, we had to understand that the view holders are recycled where possible, and in this case, it's definitely going to recycle it as we only have 2 things on the screen. So we must set absolutely every value when we set the data on our view holders. So that's what we've done for the flags. We add the flag if it's complete, and we clear or remove the flags if it's incomplete. Let's move now to the slightly more complicated bug with the strange star looping thing. You can see things go a bit weird, some kind of weird infinite loop. Okay, so what can possibly be happening there? I'll just stop the app from looping round and round. Well, the problem that we now have is we have in task fragment a task updated listener, which will then fetch all tasks again. And then in the adapter, we have a checked state change listener, which is listening for any changes in the check state of our checkboxes. So the infinite loop happens because when the user checks a checkbox, we let the fragment know that the task is updated. It then goes and updates the task in a background thread, loads the tasks again, and in loading the tasks again, it can cause the checkbox check state listener to fire again, because we're recycling the previous views, and you end up in a sort of loop. The checkbox has changed, the task is updated, we load them again, the checkbox changes, and so on, okay? In a nutshell, it's not good for us to have a task updated listener and then a check state change listener in a recycler view. So, without getting too deep into the never-ending loop part of the check state change listener, the very simple thing to do is rather than listening for the check state changing, we'll instead just add a regular on-click listener, as this requires the user to actually tap it, whereas the check state change listener can happen when the view holder is resetting itself. So now we're going to go back to the very simple on-click listener, so binding.checkbox.setOnClickListener, and here we can simply get the binding.checkbox.isChecked property. So once they check the checkbox, after onClickListener fires, this will be true, This is a very simple way to get the true or false of the checkbox. So now we can do, if I just quickly delete this, a new updated task. Our updated task equals task.copy, and isComplete can equal the binding.checkbox.isChecked. Okay, I'm going to go ahead and delete the check state change listener. That's causing an infinite loop. It's good to know that we can observe the state of a checkbox like this, but now because we have this strange looping thing and threads happening, it's going to be better to not use this. So I'll delete that. I'll delete the toggle star check state change listener as well. And for the checkbox, we will then call listener.onTaskUpdated with this updated task. And I'll copy that, do the same for the toggle star. So toggle star, making sure to get the value of the toggle star checkbox and update the isStarred property, not isComplete. So we've simplified the logic a bit. We're not going to listen for the checkbox state changing, as when we're updating our tasks, we're sometimes getting into an infinite loop. Instead, we'll just respond to plain old clicks. So when we call set tasks and notify the data set has changed, these click listeners won't accidentally fire like our check state listener was firing sometimes, okay? So that should be all we need to do to fix the bugs. If we go ahead now and run this, and I can play with this, check, uncheck, I can toggle that very fast, no problem. Okay, I can toggle the star, I can do all the stars and the checkboxes, and we're not finding that same strange looping problem that we had before. And that's because we've simplified the way that our listeners work, and we're now only listening for clicks, not the checkbox state being changed, which can sometimes fire when the view holder is binding again. And that is now working as expected. In the next tutorial, we'll be looking to do some simple sorting of our data, as you'll notice that whenever I select a task to cross it out, it stays exactly where it is, and normally you'd expect your completed tasks to move to the bottom, so all of your incomplete tasks are on the top. So in the next tutorial, we'll look at a very simple way that we can sort our tasks to make sure that any complete tasks are moved to the bottom.